Hello everyone, welcome to Bodha Academy. I am Kamalakar, lecturer in physics. In this video, we will discuss concepts and formulae related to gravitation chapter. There are four basic forces: gravitational force, electromagnetic force, weak nuclear force, strong nuclear force. Among these forces, gravitational force is weakest force. Strong nuclear force is strongest force. Between two protons separated by same distance, the ratio of gravitational force is to weak nuclear force is to electromagnetic force is to strong nuclear force is 1 is to 10 power 31 is to 10 power 36 is to 10 power 38. Newton's law of gravitation. The gravitational force of attraction between two masses m1 and m2 separated by distance r is given as F is equals to g into m1 m2 by r square, where g is universal gravitational constant and its value is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. Radius of Earth r is equals to 6400 kilometers. Mass of Earth is equals to 6 into 10 power 24 kg. Mean density of Earth is 5.5 into 10 power 3 kg per cubic meter. The relation between small g and capital G on surface of Earth is given as small g is equals to gm by r square, where small g is acceleration due to gravity, capital G is universal gravitational constant, capital M is mass of the Earth, capital R is radius of the Earth. Variation of g with height or altitude. On surface of Earth, acceleration due to gravity is equals to capital G capital M by r square. At a height h from the surface of Earth, the value of acceleration due to gravity is given as g dash is equals to gm by r square, where small r is equals to capital R plus h. Capital R is radius of the Earth, h is height of the object from the surface of Earth. Acceleration due to gravity at a height h is also given as g dash is equals to gm by r plus h whole square, or g dash is equals to g into by r plus h whole square, or g dash is equals to g into 1 minus 2h by r. Variation of g with respect to depth. Acceleration due to gravity is given as g is equals to 4 by 3 pi r rho g, where rho is density of Earth. At a depth h from the surface of Earth, acceleration due to gravity is given as 4 by 3 pi r minus h into rho g. Acceleration due to gravity at a depth is also given as g dash is equals to g into 1 minus h by r. At center of Earth, acceleration due to gravity is 0. The variation of acceleration due to gravity with respect to distance is as shown in figure. Variation of g with latitude. At 5 degree latitude, the acceleration due to gravity is given as g phi is equals to g minus r omega square into cos square phi, where g is acceleration due to gravity at poles, capital R is radius of Earth, omega is angular velocity of rotation of Earth. At poles, phi is equals to 90 degrees and acceleration due to gravity at poles is 9.83 meter per second square. At equator, phi is 0 degrees and acceleration due to gravity at equator is 9.78 meter per second square. Angular velocity of Earth is given as 2 pi by capital T. As time period is 24 hours, angular velocity of rotation of Earth is given as 2 pi by 24 hours. If the angular velocity becomes 17 times present angular velocity, then the apparent weight of body at equator will become 0. Intensity of gravitational field. It is gravitational force experienced by unit mass kept at a point in gravitational field. That is, it is given as E is equals to F by m. Intensity of gravitational field at a point P due to a mass m is given as E is equals to Gm by r square. Null point. It is a point where resultant intensity of gravitational field is 0. Distance of null point from smaller mass m1 is given as x is equals to d divided by under root m2 by m1 plus 1. Gravitational potential. It is the amount of work done to move a unit mass from infinity to a particular point in gravitational field. It is given as V is equals to W by m. Gravitational potential at a point P due to a mass m is given as V is equals to minus Gm by r. Gravitational potential at a point due to multiple masses is given as V is equals to minus G into m1 by r1 plus m2 by r2 plus m3 by r3 plus dot 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 mn by rn. Gravitational potential energy of a system of two particles is defined as amount of work done in bringing these two masses from infinity to their respective places. That is, it is given as U is equals to minus G m1 m2 by r. Maximum value of U is 0. If mass m is at a distance r from the center of Earth, then U is equals to minus G mm by r. Where capital is mass of Earth and small r is equals to r plus h. Kepler is radius of Earth and small r is distance between Earth and object of mass m. Gravitational potential energy is also given as U is equals to Vm, where V is gravitational potential. If mass small m is on the surface of Earth, then gravitational potential energy U is equals to minus G capital M small m by r, where r is radius of Earth, capital M is mass of Earth, small m is mass of body. Work done to move an object from the surface of Earth to infinity is given as W is equals to minus G capital M small m by r. Change in potential energy when an object is raised from surface of Earth to a height h is given as delta PE is equals to mgh divided by 1 plus h by r. Work done to raise an object from a height h1 to a height h2 from the surface of Earth is given as W is equals to G capital M small m into 1 by capital R plus h1 minus 1 by capital R plus h2. Consider three particles of masses m1, m2, m3 as shown in figure. Then gravitational potential energy between these three masses is given as U is equals to minus capital G m1 m2 by r12 minus capital G m2 m3 by r23 minus capital G m3 m1 by r31. Kepler's laws. All planets move around the sun in an elliptical orbit with sun located at one of its focal point. The near point is called as perihelion point. The far point is called as aphelion point. Kepler's second law. The radius vector drawn from sun to planet sweeps equal areas in equal intervals of time. That is, aerial velocity of planet around sun is constant. Aerial velocity means rate of change of area with respect to time. According to Kepler's second law, aerial velocity is equals to capital L by 2m. where capital L is angular momentum of planet about the sun. Small m is mass of planet. Kepler's second law is based on law of conservation of angular momentum. Also from Kepler's second law, the speed v of a planet in an orbit at an instant is given as v is proportional to 1 by r, where r is distance between sun and planet at that instant. When r is small, then v will be large and vice versa. Kepler's third law. The square of time period of revolution of a planet around sun is directly proportional to cube of average distance between sun and planet. That is, t square is proportional to r cube, where r is length of semi-major axis. Orbital speed. It is speed required for a satellite to revolve in a particular orbit at a height h from Earth's surface. It is given as V0 is equals to under root capital G capital M by small r, where small r is equals to r plus h. For a satellite which is revolving close to the surface of Earth, h is neglected. In such case, V0 is equals to under root capital G capital M by r. Also, V0 is equals to under root small g into capital R. On Earth, the value of V0 is 7.92 kilometers per second. Time period of an orbiting satellite. It is given as time period is equals to distance by speed, that is t is equals to 2 pi r by V0. It's also given as t is equals to 2 pi into under root small r cube by capital G capital M. From this relation we'll get t square is proportional to r cube. If height is very small compared to radius of Earth, then time period of revolution is given as t is equals to 2 pi into under root capital R by g, where capital R is radius of Earth, g is acceleration due to gravity. On simplifying, its value is equals to 84.6 minutes. Energy of satellite in an orbit. A satellite revolving in an orbit will have potential energy, kinetic energy, and total energy. Potential energy is given as minus g capital M small m by r, where capital M is mass of planet, small m is mass of satellite, and r is distance between centers of planet and satellite. Kinetic energy of satellite in an orbit is given as k is equals to g capital M small m by 2r. Total energy of a satellite in an orbit is given as minus g capital M small m by 2r. The ratio of potential energy, kinetic energy, and total energy is minus 2 is to 1 is to minus 1. Escape speed. It is the minimum speed with which a body must be projected upwards from the surface of Earth so that it escapes from its gravitational pull. Escape velocity is given as V is equals to under root 2 capital G capital M by capital R. Escape velocity is also given as under root 2gr. The relation between escape velocity and orbital velocity is given as V is equals to root 2 V0. On Earth, escape velocity is equals to 11.2 kilometer per second. Escape velocity is equals to capital R into root of 8 pi rho g by 3, where rho is density of Earth. If a body is projected with a velocity equal to n times escape velocity, then the velocity of body at infinity is given as v is equals to square root of n square minus 1 whole thing into ve. Escape velocity does not depend upon angle of projection and mass of the body. Thank you. Do like, share and subscribe.